Welcome to the Hemp podcast. Tonight we have with us Jeff Lowenfels. He's from Alaska, USA. He's a respected author and a passionate advocate for organic gardening. He's known for his infectious sense of humor and great talks. He has built up a reputation as one of the most interesting speakers in the gardening world. His work focuses on educating gardeners about the natural processes that regulate soil health and plant nutrition uptake, with a strong emphasis on organic and sustainable practices.
Correct.
Welcome.
Thank you.
How are you?
Doing great. Couldn't be better.
You're in a familiar environment. It's -6.5.
Feels like home.
Yeah. Let's start.
Sure.
Can you tell us about your journey into organic gardening and how you became an expert in soil science?
Yeah, let me see if I can reduce this to an elevator pitch. I used to be a very chemical gardener. And the reason why I was a chemical gardener is because my father had an employee. My father was in the butter business. And he had an employee who graduated from the University of Pennsylvania with a degree in advertising. And he sold butter, but he hated it.
Okay.
It was a terrible job. He didn't like the work. He drove around on the weekends, and one day he discovered a place in New Jersey where there were some beautiful flowers. And he asked the owner how he got the flowers so beautiful. And the guy said, I have a special secret chemical fertilizer. And so my father's employee decided that maybe he and this gentleman should go in business together. And they started a company called Miracle Grow, which is in the United States is a gigantic chemical fertilizer company. Now they have another partner called Scott's Miracle Grow. They sell lawn food, all sorts of fertilizer, but it's all chemical. He worked for my father, and then he quit to go into this business. And but while he worked for my father, he put my picture on a margarine package called Happy Boy Margarine. It's still for sale today.
Really? With the same picture on it?
Same picture on it. My family doesn't own the business anymore.
How old were you then?
I was probably about 6.
Really?
Yeah.
And this is allowed?
This is allowed.
Okay.
My father allowed it to happen, and so I became the symbol of this. But so I used this Miracle Grow because he was a friend of the family, and so I was a big proponent of Miracle Grow because we knew this gentleman who owned the company. One day, a friend of mine started arguing with me about organics, and he kept saying organic is a better way to go, and I kept saying, well, I don't think so. It doesn't matter to a plant whether the nitrogen it gets comes from a powder or whether it comes from manure. Doesn't make a difference.
And what's the difference between these two elements?
Well, one would be Miracle Grow in a chemical powder, and one would be just regular compost or manure or something of that sort. They both provide nitrogen, and that's what I thought the plant needed, just nitrogen.
That's it.
And it didn't matter where it came from. Well, he sent me a picture of a nematode. A nematode is a hair-like worm. It's a true worm. Has a digestive system like a worm, but they look like little hairs. And a lot of them are actually microscopic. But this nematode was being strangled, looked like it had literally been lassoed with a rope, and it was being strangled by a fungus. Now, this nematode was trying to get into the root of a tomato plant, and this fungus was protecting the root of the tomato plant and killed the nematode.
But still a separate organism from...
Yes,
Really?
separate. But it was there in the root zone, eating the nematodes that were also trying to get into the roots. And
Like a defense force.
Well, yeah, a defense force, but indirect. It wasn't there really for the plant. It was there for its own nutrition. So,
But why is it doing it?
because the nematodes eat, various roots. You have problems. They eat other organisms, but in this instance, that nematode was trying to get to the tomato root, and the fungus killed it, and then of course digests it externally. They put out acids and they digest it. So he sent me that picture, and he said, "You lose," and I didn't know what he was talking about. He wrote the word soil food web underneath.
Okay.
So I started to do research. This was many, many years ago, and I went on the internet back when it was early, and I found a diagram of the soil food web, which is nothing more than the series of food chains that exist in the soil. The little guy gets eaten by a bigger guy, who gets eaten by a bigger guy. Well, all of these chains exist in the soil. Different things eating different things, and every now and then, something on one of those chains looks up and sees another chain and grabs it off another chain. And so you end up getting a web of these chains. And the activity that occurs in these webs results in food being produced, nutrients being produced that the plants can use. And you don't have to add anything. It happens because of the microbiology in the soil. Well, the more I read about it, the more I learned about it. I went from seeing diagrams, pencil stick picture diagrams, to more realistic pictures of, a plant with roots and all sorts of organisms and little guys and
Bacteria.
Yeah, it was really something, and it just opened my eyes up, and it caused me to sit back and say, wait a minute, I've been putting chemicals down on my plants. I've been putting chemicals into my soil. And what those chemicals do are two things. One is they change the diversity concentration of the microbes in the soil. So,
We're removing elements.
well, what they do is they go into the soil, and then things that eat even those chemicals come to those chemicals and digest them. And so what happens is, instead of having a normal soil profile, you end up getting a concentration of whatever microbe happens to like that particular chemical fertilizer. And it does so to the detriment of a lot of the other things in the soil. So you get a higher concentration of one and lower concentrations of others. It's not a natural system. Now, the plant can still live because these chemical fertilizers contain all the nutrients that a plant would need. They are digested by microbes who put a charge on them so that they can go into the plant. You need an electrical charge on all of the nutrients, except for boron, so that they can go into the plant. And it's the microbes that put that charge on. So if you have a mix that's not balanced, that's not proper, you end up getting some nutrients, higher concentrations, other nutrients, lower concentrations, and you have to fiddle around and try to get the system to work. So as the more I learned, the more I began to discover that it was the microbes in the soil that I wanted to concentrate on, not putting chemicals into the soil, and that if I put microbes in the soil, I would get different reactions from the plant. And so compost, for example, contains all the stuff, and then I learned how the system really works. And so let me just quickly go into that. You have photosynthetic energy that goes into the plant. The plant uses that energy, probably 50 to 60% of it, to produce things that drip out of the roots called exudates. Now, we're sitting here, we're exudating right now, we're sweating. And that sweat comes on our skin, and it attracts bacteria and fungi that protect us. If we, in fact, were able to really remove all of those bacteria and fungi, we'd be dead in 48 hours because bad guys would come in and get us. But that doesn't happen. So these exudates drip out of the root system, and they are designed by the plant to attract bacteria and fungus. The bacteria and fungus eat the carbon that's in the exudates, and they're right in the rhizosphere, that area right around the roots. And they're thriving, and then all of a sudden, the things that eat bacteria and fungi move in, and they start eating the bacteria and fungi. These are protozoa, which nobody ever understands, but when I point out that you probably studied protozoa in high school, so we're talking amoebas, we're talking parameciums, those kinds of things, they eat lots of bacteria. And then you have things that nematodes, and they come in, they eat bacteria, and they also eat fungi. And so the next thing you know, you've got a lot of poop being produced, for lack of a better word, by the nematodes and the protozoa. And when they digest, in order to get their carbon, the bacteria and the fungi, there's excess. That poop turns out to be nutrients in plant usable form. It has a charge on it, and it's ready for the plant to use, and the plant absorbs what it needs. Now, if the plant's not getting what it needs, it can change and will change the exudate mix in order to be able to attract the right kinds of bacteria and fungi to be able to attract whatever it needs. So it's a beautiful system, and it happens naturally. And it's what really grows plants. When you go into the California redwoods, for example, who fertilizes those big trees? Nobody. It's these little microbes down in the root system in the rhizosphere that are feeding that gigantic tree.
But where does this comprehension come regarding bacteria and fungus? Why is this the common sense is that this is a bad thing?
Right. Well,
where does this come from? Why do we have this need to control and get rid of this with these elements that you say are just protecting us?
Right. Well, let's go back in time. Before World War I, and certainly before World War II, people were organic gardeners, naturally. Organic for everybody. They were basically organic. We had all of these munitions that were left over from the wars. They happened to contain tremendous amounts of nitrogen. And so what developed was a fertilizer industry with these materials. And so the fertilizer industry grew and grew and grew, and everybody forgot about the old system, how we used to do it. Because you could throw these fertilizers on, they grow plants for sure, but that's not the only thing they do. They end up changing the structure of the soil. Soil structure is incredibly important, so that when it rains, you'll get good drainage. You've got the ability for air to be able to move through the soil because all the organisms and the plant needs oxygen. And so it becomes a different soil structure when you use these chemicals. So, for example, worms do not like the smell of a lot of these artificial fertilizers. And so they go away. They leave. Well, if the worm is gone, then you don't have the worm burrows. You don't have worms pulling down leaves into the soil and decaying them out. The worms transport all sorts of microbes on their skin, so they're not doing that. You end up with fewer bacteria. The bacteria themselves produce a slime. When you brush your teeth in the morning, you're taking off bacterial slime. Well, that slime sticks to individual particles of soil. Then the fungal wrap those particles together and make big aggregates, and they're not square. So you get porous spaces, and that's soil structure. And if you don't have these things acting properly, you get poor soil structure, and it's much more difficult for the plant to survive. So the organic system was the system we used until we had to figure out what are we going to do with all these extra munitions.
So it doesn't have anything to do with that we have like overpopulated and we need it in bigger bulks and.
Well, that is.
Could we survive? What are we? 9 billion people on Earth by doing only organic growing. Could we do this?
Well, that's a big question people ask. I think we can. Some people say no, you can't. But do we have a choice? If we continue to use the chemicals and degrade the environment and reduce our soil capabilities, the other thing that happens is that the soil becomes friable and blowable. So, for example, in the United States, you can lose an inch or two of soil every year from the surface just by wind blowing it away. And it blows it away because it's not sticking together. Doesn't have the fungal, the soil structure is gone. I've been told that there's a UN report. I haven't been able to find the report, but I've seen many references to it that we have about 60 growing seasons left on Earth because of how badly we've treated the soil. that can obviously not sustainable.
And that's 60 years.
60 years, that's right.
Yeah. Before we go into, I want to hear a little bit about how the hemp plant cleans and stabilizes the soil. Now we have October.
Mm-hmm.
The leaves are falling down to the grass and to the ground.
Right.
And I've discussed this with my neighbors, one of them living here in this house over there.
Mm-hmm.
He's collecting all the leaves. He's putting them in plastic bags, 20 bags, and he's driving them away.
Yeah.
Until last year, I offered him to, instead of driving it away, I've made a big compost outside for his leaves and my leaves as well. But should I remove the leaves from my lawn?
No.
Or where I have my trees, and
No.
Should I just leave it on?
I leave it on. So years and years ago, well, the general rule that people used to have when I first started writing garden columns 50 years ago was that leaves would smother the lawn in the fall. So
Exactly, and create moss.
So you had to rake them out and pick them up and so and I believe that. And so one day I found myself in Asia. When the leaves had fallen in Anchorage. And so I was unable to do anything about it. I didn't rake any of my leaves. In fact, I used to run them over with a lawnmower and just, and then I would rake them. It's just, and lo and behold, the next spring, the leaves were all gone. Wait a minute. Why am I raking my leaves if they're going to go away naturally? What happens is you get a layer of snow. Yeah. And then you get a small little area between the lawn or the soil. And so there's actually activity in there, probably more microbial activity there than in the summertime. And it's just unbelievable.
Do I need to shred it? Do I need to shred it?
You don't.
I just leave it?
Just leave them.
Really?
Yeah, just leave them. I mean,
this is a lot of work. A lot of plastic bags.
Absolutely. And then I do what you do. So if you leave the leaves, then what do you put on your compost pile? So I had to go around my neighborhood. I find a house where they have loaded up the leaves in black plastic bags and left them on the sidewalk for the garbage people, the refuse people.
And you remove them?
Only if I know there's no dog at that house.
Why? What do you mean?
I don't want dog poop.
Of course, of course.
So I get the leaves. I probably pick up 30, 40 bags of leaves every year.
To compost?
I compost them. I use them for mulch on all of my beds. There is no bare soil in nature. When you think about it, soil has always got a little coating on it.
Do you need to stir it? Because I have a big open compost. Do I need to stir it?
No, you don't need to.
I can just leave it, and it just takes care of itself.
Yeah, it's called cold composting, and then if you have the worms, you get a little bit of vermicomposting at the same time. It takes longer.
Interesting.
So if you turn it, you can make compost. You can make soil in almost 30 days. I mean, if you turn it the right way, you get it to heat up the right way.
Otherwise, it takes just longer time. But it will happen.
It definitely will happen. It will definitely happen. But the idea, and I live in Anchorage, Alaska, which is similar to here. I write the garden column in Anchorage, Alaska, and people have learned that they can trust me. And basically what we've done in Anchorage is we keep our leaves on the lawns. We run them over with a lawnmower sometimes to mulch them up, makes it a little bit easier for the decay. This has resulted in not needing to ever fertilize your lawn. No. And it's resulted in a big savings in terms of the landfill. Yeah. So when you take those 20 bags of leaves, your neighbor, to the landfill to dump them, they take up valuable space. It's expensive to put a landfill in. You have to line it and blah, 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 blah. And so we're saving space in the landfill. Plus, we're getting all this great nutrient material for our trees and grass and everything.
Perfect. Yeah. I will broadcast this throughout the street. Regarding, the cleansing abilities the plant has, how does hemp? Because I've heard it cleans the earth for poison and stuff like this. What does the hemp do for soil?
Well, my understanding is that it has the ability. It's not my area of expertise. It has the ability of taking up a lot of detrimental nutrients, heavy metals and things that are taken up into the plant as part of the process. Reminds me, I've got four books on soil.
Yeah.
So the first book I wrote was Teeming with Microbes, and it explains this whole soil food web system in great detail, and it's got some rules that you need to follow if you want to garden or farm using the soil food web. So it's a complete book. But after I wrote the book, I started to think, I'm a very curious guy. I started to think, all right, so I know how the food gets to the plant. You've got all this eating and pooping. How does it get in the plant? Have you ever thought about that? How do nutrients move into the plant?
And what through the root system must be.
Yeah, but how? You know what I'm saying? I mean, through the root system. Well, that doesn't. You walk in through a door, but how do you build that door? And so I wrote a book called Teeming with Nutrients, which explains what happens once the nutrients are made, how they move into the plant. They move through these very special pores in the cell. Each pore is designed for one particular nutrient. And it turns out that some of the nutrients, like heavy metals and things, are similar to just regular nutrients, and they end up going in through those same pores. So if people are interested in the soil food web, they should read the first book. The second book will explain what happens to that soil food web inside the plant. And then once it gets in the cell, fascinating.
Where does it go?
Well, it goes into the cell, and then once it's in the cell has tremendous numbers of enzymes. You think about it, everything in that plant, on that plant, has been made in the plant. It's an incredible factory system.
From almost nothing.
From these little teeny individual nutrients. And so inside a cell, you might have 1,000 different kinds of enzymes, which are needed in order to build various things. And you may have 10,000 of each one of those 1,000 enzymes. And they're
it's like a galaxy.
Oh my gosh. And they're just connecting to something and putting another thing together, and and if you had if it was a single cell was like a football stadium, you'd have trucks all over the place, which would be the mitochondria with generators. Yeah. And you'd have activity and explosions and electrical, and there are these nanowires that move stuff along.
It's conscious.
It's unbelievable. And there is a wonderful animation done by Harvard University. I think if you go on the internet and look up life in a cell, Harvard, I think it'll show you this animation, and it is unbelievable. It's just will change you will never feel the same way about a plant again when you see this.
This is the thing. We don't see this with our naked eyes.
Right.
And that's why we don't take it in as a reality.
Exactly. And that's why we think we're smarter than the plant, because they're these dumb animated things that can't run around. But if you walk up to a tree and touch that tree, every cell in that tree knows you're there. Instantly. Well, because they're all connected. You could travel through from the root all the way through the system, going around all of the cells, or you could go through each individual cell all the way up. It's incredible. And people just don't study it. No. Part of the reason is because most of the stuff written is very thick and hard to read.
But, talking about studying things, how can cannabis growers benefit from understanding soil nutrients and
one of the things I talked about yesterday was a new process that we've discovered called rhizophagy.
Okay.
Rhizophagy is a cycle whereby bacteria move into root cells. And when they're in the root cell, through a series of chemical reactions and interactions between the cell and the bacteria itself, you end up having nitrogen produced inside the cell. Oddly enough, those same bacteria produce nitrogen in the flower of the hemp and the cannabis plant. And in order to produce this nitrogen, they need an oxygen-free environment, and so you've got the reaction between the plant and the bacteria actually produces the THC in the plant. It's absolutely fascinating stuff. I covered that in my last book, which is called Teeming with Bacteria. This rhizophagy cycle, which was discovered only in 2017 and is now really being promoted by a gentleman named Dr. James White.
Okay.
He's at Rutgers University, and if you Google Dr. James White, you'll see tremendous numbers of articles. You'll see some wonderful YouTube videos of Dr. White giving his lectures, and it's your listeners, people who are listening to this, are probably among 50,000 or 100,000 people who have ever heard of the word rhizophagy. Mm-hmm. Every plant that has a root hair, that has root hairs, has this cycle going. The bacteria are what causes root hairs in plants, and yet most people have never heard of it. They will.
Is this the same thing I see in the garbage if I leave it for a long time? Garbage or an indoor compost where you get these white, like furry hairs all over the place.
No, that's fungus.
That's fungus.
That's breaking down stuff. No, this is purely bacteria.
Okay.
Which is really, really something else. And the photographs now that they have, because we've got new ways of discovering, of viewing these things with these new kinds of microscopes they've got. It's changed the whole viewpoint of how the soil food web works. I learned the soil food web as a result of my friend sending me that picture, telling me I lost. I found these diagrams, and I ended up reading the works of a woman named Dr. Elaine Ingham, Ingham. She is the guru of the soil food web. When she discovered and worked on the soil food web, the microscopes were very different. And there were organisms and things and viewpoints that she never had an opportunity to see because we didn't have the microscopes. No. Today, 15, 20, 30 years later, that was, 2000. Today, we've got different microscopes. We can see different things. We can stain things differently. We can see the bacteria literally producing the nitrogen in these pictures because you can stain it. The nitrogen comes blue. Fascinating. Absolutely fascinating, all the stuff we've been able to learn.
And regarding to this, does the soil, healthy soil, does it influence the quality and the quantity of cannabinoids in the plant?
Yes. And again, I think it's the bacteria that do it.
Is it sufficient? Is it a lot?
I think what you're asking is does it cause is there a terroir?
Yeah.
When people say, "Oh, this wine grows in California; it's got the California terroir," what you get is the terroir developed by the bacteria and the fungi that are in the soil, and it's the bacteria in particular that go in there and through the process. And again, if you read Dr. White, the last paper that Dr. White wrote, and I highly encourage people to do look him up, talks literally about the trichome and how the THC and the cannabinoids, those cannabinoids are what prevent the oxygen so that the bacteria can produce nitrogen in the flower. Now, we used to not know exactly what those wonderful trichomes did. People used to think, oh, those trichomes are there to prevent UV light from destroying the flower. Those trichomes are there because the plant is producing nitrogen in them
from the inside. Makes the essence stronger.
Well, it makes the plant stronger.
More potent.
It makes the plant better. Stronger.
Yeah. Do you have any stories, like a success story from growers who have implemented your practice?
Well, I spent quite a bit of time in Oregon, which is one of the states in the United States that has legalized cannabis, and now in Alaska we've got legalized cannabis as well. And what I find now is, in fact, I remember the first cannabis store I walked into, just legalized it. There was what we called the bud tender behind the counter. And she saw me walk in, and her jaw dropped. I said, "What's wrong?" She goes, "Did you write this book?" And behind her, for sale, was my Teaming with Microbes book. Yeah. She said, "The owner of this dispensary uses your system to grow his cannabis."
Really?
Well, this was many years ago. Yeah. And today, when you walk into a lot of the cannabis stores, you see the words living soil, grown in living soil. That means it's organic. It means it's using the soil food web. Who wants to...
It's not interrupted but with chemicals.
Right. And so when we say medical cannabis, which you're beginning to talk about here in Iceland, what part of medical cannabis includes chemicals? Why would you want to take a chemical in when you could be just using the natural plant? Now, in addition to which, it turns out you can taste a lot of these chemicals. So for years, people grew, they grew hemp and cannabis using hydroponics. You could taste the nitrogen. You literally could taste the difference between a hydroponic and a soil grown. So I kind of laugh because you walk into dispensaries now all over the country in the United States, grown in living soil. Yes, we're there. It's really quite something. It is a success, and it has nothing to do with me. It's the system works, and it produces a better plant. Now, again, we tend to think that plants are stupid. They're not. And you give them what they need,
they will take care of themselves.
They'll take care of themselves.
So how do you envision the future of sustainable growing practices? How do you think it will be evolving for the next decade? Where are we, and where are we going, you think?
Sustainable gardening and regenerative is the word that people use. I think it's going to not only include treating the plant better. I know it's going to include treating the plant better, but it's also going to include treating the environment better, and that includes the worker.
And our health.
Well, the worker, exactly. And our ultimately, when you buy the product, it's our health. But the flower industry, for example, I write this column once a week, and I always tell people, think twice about buying your spouse or your boyfriend, girlfriend, whatever it is, flowers.
Imported flowers.
Imported chemicals like crazy, bad enough that, those beautiful roses. You think of the workers who have to deal with this stuff and the problems that they have and their families. And then we end up paying for it one way or another, all of us as humans. And so we're going to see a system that's going to be much more organic. And I'm quite certain that we're going to see a system that's based on biofertilization rather than chemical fertilization. So we now know that certain bacteria and certain yeast are better in this rhizophagy cycle than others. We're now able to take DNA tests. I'm convinced at some point in time in the next 5 or 10 years, we'll be able to do it using our phone. And so we're going to be able to apply things to plants that go into the plant and produce the nutrients that they need inside the plant. We're going to be able to apply biofoods.
Just a stimulation for the system that is already there.
Exactly. With a little bit of attention to the people that are putting the system into use. And it's going to be quite a big difference.
Yeah. Jesus.
Yeah.
Do you have any last words before I let you go?
Last words. Well, again, I think people need to appreciate plants much more. They are...
We need to see them.
We need to see them. We need to understand how they work so that we can get along with them. And they're not these dumb things that just stick in the ground. They're incredibly active, incredibly
intelligent.
Air quotes around intelligence. You think about a tree that just stays in one place for 700 years or 500 years. Wow. It's just bringing all the food into itself and all these wonderful things that go on. Plants are amazing.
They're the boss.
Yeah.
Thank you, Jeff, for coming.
Pleasure.